I've always been fascinated by collective behaviour. Whereas most people have been focusing on how the individual organism behaves, what we see around us in the natural world are organisms interacting with each other in bird flocks, fish schools, animal herds, and even our bodies are a collective of cells. So really, we need to understand not just the individuals, but how communication and social interactions among individuals give rise to these ubiquitous patterns that we see around us every day. Studying collectives is not only fascinating, it's also really, really important. For example, fisheries are being heavily impacted by humans. We're losing migratory species across the planet. We're massively impacting ecosystems. And in many, many cases, it's the collective species that are most at risk. So they're the sort of early warning indicators of ecological catastrophe. So we must understand how and why and where we are impacting collectives to understand how we can conserve them, and also understand and predict where we're going to have major changes to life on this planet. One of the great challenges of studying collective behaviour is asking how we can track the motion of all of the individuals simultaneously. And so originally, when I was starting my research, I was so frustrated because I couldn't keep track of more than one ant at a time, yet I'm looking at the colony as a phenomenon. And so what we realised even back then, more than 20 years ago, is we can use computer vision. We can program computers to see the world for us, and they're not constrained in the same ways that humans are constrained. So we've been pioneering and developing these tools, computer vision tools that allow us to track the motion of many, many animals simultaneously, hundreds, even thousands of organisms simultaneously. Now using deep learning technology and artificial intelligence, we can identify different individuals based on pattern differences that we can't even see as a human. And so we can keep track of individuals, we can track the full body posture of individuals, we can reconstruct computationally the visual field so we can see the world from the perspective of each individual. And this gives us completely new insights into both the functioning and the evolution of animal collectives. We've discovered that army ants use traffic rules. These are blind insects, and yet they can seamlessly form lanes, roundabouts, and living bridges out of their bodies to minimize congestion. And this is directly informing us about how we could control autonomous interacting vehicles. In addition, in our studies of locust swarms, it looks cooperative. They're all marching together across the desert environment, as if by one, in unison. Yet in actual fact, what we found was that each individual is cannibalistic. They're trying to eat those ahead and trying to avoid being eaten by those behind, stop and you risk being cannibalized. So in actual fact, it's not cooperative. They're on a forced march for essential nutrients, themselves, their own bodies being the perfectly packaged source. Collectives can also inspire new technological solutions. For example, we've developed biomimetic robots. They swim like fish, they interact like fish, and this saves them energy when they're exploring the ocean, for example, for pollution. We are creating the world's global hub for the study of collective behaviour here in Konstanz. In addition to having this amazing building, the VCC, we also have an incredible opportunity to bring together scientists from diverse areas of study in the Centre for the Advanced Study of Collective Behaviour. This involves biology, physics, social science, economics, psychology, and many other subjects here at the University of Konstanz. And it's only by bringing together these different areas, because collective behaviour is the vital key ingredient. By bringing together these different researchers, we are creating the best place in the world to study collective behaviour.